can't see it here, which is whatever. Okay. Why are you going on that? Okay, so Blaze is this library. The question mark is intended in the title of my presentation here because it is definitely a question whether Blaze will be the future of NumPy. But basically, a couple of the NumPy developers, especially one of the original NumPy developers, has recently decided that he is going to switch to working on Blaze full time, basically, and he wants to basically make Blaze into the library for NumPy. Now, Blaze is not a replacement for NumPy; it's more of an add-on package for NumPy. We'll sort of talk about that. So, you know, by and large, NumPy does everything you want. This is that company, Continuum.io. That's actually also their website, so you can visit them. They got $3 million in DARPA funding to build this out. It was already sort of started. It's definitely a work in progress. We'll talk about that. And yeah, that's the URL. I think this sums it up. One of the reasons why you want something like Blaze. What about something like this? I've created an array of 15 billion items. If you try to do this, and you have like less than 96 gigs of RAM probably, your computer nothing will happen. It will take forever, basically. So this is one of the many problems that Blaze is trying to solve. So, you know, NumPy is great. It was sort of built for a time and for the hardware that it was built for. And so this Blaze, I would say, is more optimizations and other things built on top of NumPy to try to help it alleviate some of the issues with NumPy in terms of you know, the strategy for how you deploy it, how you distribute the load, how it handles large data sets, and these kinds of extremely large data sets. So it has sort of one of the big features that it has is it operates on data disk rather than only in memory, as NumPy sort of works. So this means the normal operations that you might want to do in NumPy, multiplying every single element in a matrix, or you know, taking the cross product of a matrix or something like this, can operate on matrices on the disk instead of just matrices in memory. So for an extremely large matrix, this makes sense. It has custom shapes. I'm not as convinced that that's going to be useful, but whatever, they seem to be super interested in it. It has custom types, so instead of just saying, you know, we have sort of these types, you have a bunch more types. You can define your own types. You can have sort of empty rows, similar to how you can have in pandas, but you can't exactly, per se, maybe have that in NumPy. They have a number of ways that you can persist this data, so you can sort of start working with an array, persist it to disk, similar to NumPy, but they've drastically improved some of these things, or at least in theory, they've drastically improved these things. So for example, these, you can persist them such that they will have sort of integrity checking automatically built in to make sure that the data, you know, when you write out, say, 90 gigabytes of matrix data, you want to make sure that that it was written successfully, and that when you read it back, that all the data was read back successfully. So it sort of has these things built in. It automatically compresses the data to be allegedly extremely optimal. And similar to how pandas works, you can add extra metadata to arrays. So you know how largely NumPy is just numbers, things like that. But you can work with sort of column data with strings and other things. You can define an array such that every single thing in the array could be an integer or a float, but not anything else. Gives you lots of options like that. So of course the question is it ready? And the answer to this question is pretty much no. That's not to say that I think that you should completely ignore this, because I think it's a really interesting project. There are a lot of people actually working on this pretty much full time. So this isn't sort of your classic vaporware scenario where they're promising the moon and pretty much nothing's delivered so far. This is nothing like that. There is a working library. You can install it. Installing it is perhaps not as trivial as it could be unless you use Anaconda. I suggest you use that if you're gonna do this. They describe it. I put pre-alpha there because that is their description, their own words, pre-alpha. So they are basically saying, this is not ready for sort of production use at all, but go ahead and try it out. The documentation is thin. You will be looking at source code if you want to use this to some degree. I mean, you might. Yeah, the documentation's thin. And I would say if you were using this for sort of a production environment, you are essentially committing to Blaze development yourself. So I would say that that's not sort of out of the realm of possibility for a lot of sort of packages. I think that there's a number of sort of packages where if you decide you're going to use this and your business is going to rely on this package that you've committed to the development, this will be like that, except this is probably larger than most of the packages that you would want to commit for. This is true now. Probably in a year, maybe it will be ready to go, more similar to like how NumPy is ready to go. You can sort of rely on NumPy, it's going to work. Sure, it might be a pain to install, but once you have everything set up, it's pretty much rock solid. So I would say it's not quite ready, but take a look. Sort of future features. From what I can tell, these are totally not documented. Couldn't find that many details on these by actually looking at the code line. But these are sort of future features that I think are coming along. Some of them are more documented than others. So basically, you will be able to operate on array type data. It's pretty much regular NumPy arrays, except these would be persistent to disk in a similar fashion to how you would have a database, which does sort of yield the question, how is Blaze that different from an actual database, which does some of the same things? That is a good question. I do not have a great answer for that. Other than it has some other features that we talked about, but it is very similar in a lot of aspects to a database. NumPy had some support for sort of, it's not sort of single thread, single process in sort of a lot of the ways that sort of typical Python code is. It definitely parallelizes better than traditional Python, but the goal of Blaze is to do even better. So they want to have it, and not just do better than NumPy, but to have it be seamless, where you don't have to write code specifically that you in some specific fashion to have it work across multiple threads or multiple cores or multiple processors or potentially multiple machines. This should just work. Now, I mean, should is the operative word there. We will see how this goes. Especially this is pretty much nowhere yet. This is probably working pretty well. That's probably somewhere in between. So that's probably about where you are. The GPU integration, this same company, Continuum, actually has another project that they're working on called Numba, N-U-M-B-A, which does some GPU integration. But I think that their goal here is to wrap that into Blaze such that you do sort of you write regular code just in the regular fashion, and if it can work with, if it can be optimized with your GPU, if it can be run on your GPU, it will be run on your GPU with relatively few changes. That's the goal here. This kind of works today. So there are ways to sort of work with Numba on a GPU already, and that could tie into Blaze already. Not quite as seamless as I think they're really pushing, but this might get there. And there are lots of things that you can read about this. My personal favorite is if you go to the documentation, the first hit, and you click on examples, you get an empty page. Not to be critical, because I think that they've accurately described their software as pre-alpha, so I don't think I can fault them or anything. I just thought it was pretty funny. When I was looking for samples and reading through the documentation, going through the tutorials, which there are actually some documentation tutorials They could be polished up a little bit better, but you know, if you're willing to sort of take the dive and go look at some real early stage numeric analysis software, this is a great package to look at. I actually had a great time sort of looking at it, but in terms of actually finding, you know, hard and fast details, it was a little tough. And when you're looking through sort of the limited examples and documentation that are there, and you sort of try to run them, and the syntax has changed a little bit, this is definitely where this software is. It looks great. It has a lot of promise. It's not vaporware at all. It definitely has a lot of features already working, some kind of working, some not implemented but planned, and it has a lot of momentum behind it. So check it out. You know, I think it's really interesting, and you know, maybe when we have our 4th annual data analysis workshop, we will have a much more detailed presentation than this one. Maybe only the 2nd annual one, 2013 or 2014. So yeah, any questions? I know that I didn't really answer a whole lot of potential questions anyway, but go ahead.
Do you have any insight into some of the parallelization stuff? Seems like they'd have to go in and change the base libraries, not just services to numpy, but actually go in and change the library that's using.
What it looks like to me is that they're sort of they have their own. Sorry. They're basically, they've written or used actually a different persistence layer, and when they sort of read in, they'll read in sort of smaller chunks into a normal ND array, like a numpy array, and operate on that and then persist. And then basically they have loops to do this. So that was sort of my understanding.
Oh, not persistence. I mean, if you go back to your previous slide, you're talking multi-core, multi-processor distributed. Seems to be that they'd have to go in and rip out the libraries that numpy actually uses to replace them with more highly parallel.
Well, I don't think that they're going to like vastly be. I don't think that it's going to be that different from NumPy, but I don't think, you know, when you instantiate, let's say, like a 15 billion item array, you're not actually instantiating a 15 billion item NumPy array. You are instantiating sort of like a wrapper around that. You could probably get a 15 billion item NumPy array, but when they actually do any sort of processing, they're probably slicing this up into smaller elements and distributing it across, so that you would still, most of the processing would still be done in NumPy with normal arrays, but they're not the full size. They're sort of smaller.
Well, you're saying they're putting chunks on different cores or something.
Yeah. I know, like, I sort of read a little bit about this. This is definitely like in the architecture stage, not in sort of the ready for anything production type of stage. And it looked to me like they were going to layer this on top of Hadoop, for example. So they were going to use sort of Hadoop's distributed file system in order to distribute the data. And then you would have to. Sorry. It's yeah. So it's basically a distributed file system and for distributing sort of workloads across multiple machines. So I don't think this is going to be, I don't think that there's going to be magic here. I think it's just going to be slicing up the data into smaller slices and operating on them independently, if they can be operated independently.
So it'd be more like middleware, you think? Or?
Yeah, I mean, I view Blaze as a potentially much more ambitious project than NumPy. NumPy does sort of relatively few things, and it does them extremely well and extremely quickly. And I think Blaze, I viewed more as sort of an abstraction layer to make, parallelizing, working with modern hardware, doing all of these types of things, in a more efficient manner.
The thing I worry about in this project is that whether it's corporate controlled or whether it's community controlled.
Definitely a valid concern. So there is sort of a company behind this. There's also public funding behind this. I would say there is less public involvement behind this. However, I'm not sure, I don't know if that's going to be that different from NumPy. I mean, NumPy does have a community behind it, but in terms of a lot of the core of NumPy, it's developed by a relatively small group. So, we'll see how it shakes out. I can't really recommend its use in production at all at this point. I just sort of presented on it because I thought it was an interesting topic, and I think people should be aware of this, that this is coming down the pipeline for Python data analysis. Any other questions?
Are you looking for developers?
Are they looking for developers?
Probably not.
Probably. So they're based in Austin, if you're willing to move. But no, they're it's continuum.io. So there's they have a great blog. If you read their blog, it's usually maybe once every week or two they have like sort of it's similar to like what we talked about here. Somebody will take like an interesting data set and sort of slice and dice it up and see what you can do and put up some code samples for their that use their various products. But I think this company is definitely trying to position themselves as the data analysis company for Python. Now, just to sort of address your concern, the project is open source, so you can sort of inspect all of the code. But an open source project that's used by exactly one company is, we'll see what happens. There's not really users yet because I'm not sure it's ready for prime time. It's still very much experimental. Is there another question? Yes.
Yeah. So if it doesn't work on the file system, do you interact with those files, or are they just sort of transient and
Okay.
a segue to the output you're looking for?
So they are sort of saved along the way. When you sort of instantiate an array, you basically say, yeah, this is a storage-backed array. And then there's actually sort of a storage abstraction layer. This is sort of what I was getting. There's not exactly like great documentation on this. The typical storage abstraction layer is like a file. And it's actually not one file, but it's actually a directory with a number of files in it. But they're hoping, I think, to have the storage abstraction layer will get more complicated, and they might be able to back it with databases or
Hadoop or whatever.
So I think that's sort of where this is going longer term.
You can load a numpy array from a memory map, of course. So it's saved on file for you, but of course you still have to have the memory for it.
Right. Yeah, I mean, a lot of the features that I think Blaze is trying to do, they're not things that are impossible to do in NumPy. They're trying to make things that are tough to do in NumPy more straightforward. I think that's one of their goals. Yes.
Can you say something about what we were talking about before, the Visual Studio?
Oh, sure. Or I'll attempt to address this. So, if any of y'all have been trying to install some of these packages on Windows, you've probably run into some difficulty. It is tough to install like a lot of these Python modules that have a whole bunch of C dependencies on a platform that typically doesn't ship with a C compiler, or in the case of NumPy, a Fortran compiler and a C compiler. That's why I think a lot of the scientific community have been sort of using these distributions. Anaconda, which I was going to point at it there, but I didn't actually write it down. That is one of them, but there are others. I know that SciPy puts out a distribution. In addition, a lot of these big scientific packages that sort of require compilation, they know that these are tough to install on Windows, and so some of the more mature packages like NumPy, SciPy, they actually will ship binaries for these. If you're on a Mac or you're on Linux, these things usually, they compile pretty straightforward actually, because typically they have access to a C compiler. Although if you're on a Mac, you have to install Xcode or the GCC for OS X GCC compiler, because it doesn't actually come with the C compiler by default. But yeah, oh, actually, one other thing is this actually will use LLVM, so some of the slower parts of NumPy, which I don't think I know NumPy enough to really speak to that point in great detail, they are integrating LLVM into this so that they're going to output machine code. They're sort of, it's almost like operating their own JIT for just-in-time compiling, but basically they're going to attempt to optimize the code using a compiler. Actually, so you would write code and that would get, you would write Python code, which would on the fly get compiled to machine code. This is also one of the big reasons why it's tough to install, because now you need sort of a full LLVM distribution, or a full LLVM installation. Any other questions? All right, that was that. So thank you guys for coming. I appreciate it. I would still love feedback if anybody wants to send feedback, sandiegopython@gmail.com. Please also take food with you, because literally I don't want it. So if you don't